How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we are going to dig into wireless principles. Now, I'm going to state this out of the gate that I am not a wireless expert. I know the basics of wireless. So what you and I are going to discuss in this video is going to be the high-level details of how, I won't even say details, the high-level principles of how just about anybody that does networking should have a general understanding of how wireless in general works. So that's going to include non-overlapping Wi-Fi channels, the SSID, the subscribers, SSID, I forget what SSID stands for off the top of my head, radio frequency or RF, and then encryption. So how do we encrypt the data so that we are semi-secure? So in other words, authentication between the client and the access point. So what I'm going to do is I'm going to drag this off screen here, and you and I are just going to have a general conversation about wireless and how it all works. Well, generally. So the key thing that I like to remember when it comes to wireless is that there's no wire, right? I mean, that's the Captain Obvious response, but there's no wire involved. So when we talk about wireless, there's two different types of access points that you can work with. You have your lightweight access point that is going to need a controller, like a wireless LAN controller. And you're going to basically tell the access point in some matter of connectivity. There's a few different ways that you can do it. That the wireless LAN controller is where it should connect. And how you do that, there's several different ways that you can do that, and the idea is to tell the AP register to this controller, and then the controller will then be in charge of all your configuration. So the controller is something you log into, and then the access point would then show up as a registered AP. Then you'll be able to create VLANs and then RF groups and things like that, and be able to map multiple APs together to allow you to do things like roaming and things like that. You'll also be able to go in and do software upgrades. So if the access points need to get a software update to a newer version of code because there's a new capability that you want to leverage, then you would upload that code to the controller. Then the controller would be able to push that code over the wired distribution system. The distribution system is everything in between the controller and the access point. So that would essentially be your switching environment. Your core distribution access is your distribution system. You would then leverage the Ethernet cabling because that's how you're going to deliver PoE from the switch that the access point plugs into in order for it to A, get power to boot up, and then B, in order for the data to go back and forth. There is a tunneling mechanism known as the CAPWAP. Now, I don't know exactly off the top of my head what this stands for. I believe it's Control and Access Provisioning Wireless Access Point. There's some term to CAPWAP. I can't remember off the top of my head what it is. But they have these tunnels. And in my basic understanding, there's two different tunnels. You have a CAPWAP tunnel, which is going to be control plane. So I believe this is control plane, so I'll put CP here for short. And then you also have one that's data plane. So this one here is the one that, if I remember correctly, this one is encrypted between the controller and the access point. This one is not encrypted. So this is where your data is going to go back and forth over the wire. Now, this does not include how SD access works. There's a whole nother set of steps and complexity that goes into that. So I'm not an expert in that either. So now when we talk about RF, since we're on the topic of encryption, when it comes to like the control plane and the data plane, you do have RF encryption, where this is basically a endpoint to access point connectivity. So there are ways for you to authenticate your users. So the idea is this. if I have a user, so I'm just going to draw a very cheap laptop. Not an artist here, so don't give me too much of a headache on it. And then this guy has a wireless access card inside of it. What's going to end up happening is you're going to have an access point that's out here in the network who is broadcasting a wireless SSID. So subscriber service set ID, I think is what SSID stands for. So what's going to end up happening is you're going to have, and I always get these two confused. There's a concept known as a beacon and a probe. So the beacon, I think, comes from this guy, and the probe comes from here. Meaning the beacon is sent out, and I could have these reversed, but they are how the wireless antenna on your laptop is able to detect the wireless networks that are floating around in the atmosphere. So these two are communicating back and forth with each other. And I could have these backwards, but irregardless of whether they are backwards or not, you've got beacons and probes. I believe the access point is a beacon. I believe the client is a probe. It sends out probes to detect wireless networks. I think that's how it works. What will end up happening is you'll get a list on your laptop, there'll be a list of SSIDs that you can connect to. And so you select the wireless network that you want. So you would click on this guy, and then you would be prompted to enter commonly a pre-shared key. This pre-shared key is typically backed by one of many variations. There is WEP, the Wired Equivalency Protocol. Don't use that. That's just super old school. Nobody uses WEP anymore. Then you have WPA, Wired Protected Access, and there's multiple versions of that, 1 through 3. The most common is going to be 2. And this is where your RF encryption comes into play. This is where you would set like AES encryption, so that anybody that's sniffing the air or on the Wi-Fi and they have the ability of sniffing the traffic, they won't be able to sniff out your pre-shared key. So this is what's really being encrypted here. And there's other stuff that gets encrypted too, but the nitty-gritty details, I honestly don't know. So that's essentially what ends up happening with that. So regardless if you're doing a lightweight access point or you're dealing with an autonomous access point, meaning it's on its own, you're going to have to deal with some sort of authentication. Now you can have open Wi-Fi. So if you walk into a location and you just happen to see like Riker hanging out and there's no little lock icon, you don't see this, that means it's going to be open Wi-Fi. If you do see a lock, that means that it's going to be protected. It means you have to authenticate to it. You have to know the password to log on. Now, and by the way, no, I don't have my home Wi-Fi set up as Riker. I have it set up as something else. The other one here is going to be autonomous. So I'm going to put ATO AP, where an autonomous AP is going to be just a dedicated access point, and I draw this out for simplicity. This is going to be your access point, and he's going to send out wireless information. I have one autonomous access point in my house. It's a 3702, and it does the job. It's a gigabit connection back to my home switch, and I'm able to service, I don't know, I think I've got 20 or 25 wireless devices in my house, so nothing crazy. Between phones, cameras, people coming and going, I have a couple of 3D printers that are on it, so it's not heavily utilized, but there's still enough on it. So what ends up happening is the autonomous access point does the exact same thing. It's going to connect via PoE back to my switch, and that switch is going to be providing its power. Now that power is going to power the AP on, and then it's also going to provide the data between the access point and the switch. So anytime you see a core distribution access type of setup, this is going to be your distribution system. Distribution system is what connects your wireless network to your physical network. Now, in this particular case, and I have worked with this in production a few times, where a customer only has autonomous APs deployed. So not a very good idea if you have an environment where you need roaming to be available, which means where if I have a bunch of APs that are just kind of hanging out doing their thing, and they all connect back to the same switch or the same distribution system, but they're all autonomous. Which means if I have Bob here and he's doing his job, and then for some reason Bob needs to walk over to here and do his job over here. Well, the problem is Bob was connected to this AP, and then now Bob is now connected to this AP. So what ends up happening is Bob has to deassociate, however you want to refer to it. Bob has to deassociate from one access point, walk over to the SSID coverage area of another access point, and then associate to that one. It might be the same wireless network, and it might be the same password. But because of the fact that these APs are not sharing information amongst each other, he has a deassociate, reassociate process that kicks into play. Now, I learned about this a long, long time ago. I'm specifically talking about a customer that I was doing IT work for. This is probably 10 years ago, where the wireless users that we had, I don't know, we had a fairly sizable warehouse that I was supporting, and it was a manufacturing location that also had a warehouse, and they had a bunch of people driving around on forklifts. And these guys had, all the forklift operators had these RF guns that were used to talk back to some sort of inventory tracking system, warehouse management system, WMS, and that is how they were able to maneuver around. They knew where to go, how many items to pick from this location, and whether it was shipping, receiving, or whatever. Well, the problem is they were constantly they would be moving around, and as they would be moving around, they would constantly have to refresh their screen or go back to the last, go out of the screen to come back into it. There was a lot of issues with that because what they were having to do is they would deassociate from one access point and then reassociate to a new one, reconnect because they would lose their connection to the end system, and then somebody already grabbed that order or whatever the case might be, or they would get a new one. So it became very inefficient. So instead of them being able to go from AP to AP seamlessly through roaming, they were having to deassociate and then come over here to associate to this guy. They'd lose the connectivity they had with the end systems, with the warehouse management system, and they'd have to start all over again, or they would scan and it would go, oh, well, this isn't right, you're at the wrong location, or whatever the case might have been. So that implied, and when we saw this, I said, okay, well, we need to move over to a lightweight AP system where we can deploy multiple APs without to rebuild them. And most of the time, the APs, if you had an autonomous AP, you should be able to migrate it to if you have an autonomous AP, you should be able to migrate it to lightweight and vice versa. Not all APs do that. Your enterprise grade, most of your enterprise grade wireless access points do support that capability of moving from lightweight to autonomous and autonomous to lightweight. So, but that implies that you need to have a wireless LAN controller and that you need to know how to work with that. So that goes out of scope for my knowledge level. Like I can do basic things on a wireless LAN controller, but for the most part, I don't know a lot about them. So that's a whole nother area. There's lots of documentation online. There's lots of really good resources for you to dig into if you want to learn about wireless. That is not the area of expertise that I have. But I do know enough about wireless to tell you that not allowing your users to roam. So it doesn't even have to be like a warehouse. This could be, and I've walked into like hospitals. I support a lot of hospitals in my career. And so if you have, let's say you have a wing of a hospital. So let's say the hospital looks like a giant, looks like an H, right? So you have an H here, and then you have like the main wing, or you have the wing, so you have like the, so you have the north, you have the north 1, you have north 2, and you have south 1, you have south 2, then you have the main wing. Well, if I've got rooms hanging off each one of these wings that the patients are in, right, and I've got nurses, doctors, cardiologists, phlebotomists, whatever, any type of medical professional that is going in and out of these rooms, what do most medical professional buildings have? Well, they have robust wireless because a lot of their workforce is mobile. You're not gonna get a, and I'm probably gonna speak out of term here, a charge nurse. A nurse that plugs in for, clocks in for 12-hour shifts. Whether it's a hospital, a nursing home, or whatever the case might be. You got this nurse that's there, and they are there for that entire shift. Well, they're not gonna just sit, and I'm just gonna colloquially call this here. We're gonna say the nurse's station, right? The nurse's station sits at the end of each wing, right? They're not just going to hang out in the nurse's station. They're going to go up and down their hallway, their wing, and maybe they have to give out medication every 4 hours or whatever it is it looks like. Well, the key thing is, regardless of what their job function is, they're mobile, right? They need to be able to move around on a moment's notice without having any complications to their end job cycle. Which means, I've been to the doctor. I've got 2 kids, so I've been to the doctor's office plenty of times. Been to plenty of hospitals, supported plenty of hospitals. What is the main thing they all have? They have some sort of wireless device that's on them. And I say this more hospital than I see doctor's office. Doctor's office is a little bit more static, because I've seen plenty of doctors walk in. There's a computer set up in the room. They log in into typically Epic. That's the most common nursing or medical professional ERP system that I've ever seen. And so they do that. But in a hospital, things are a little bit more fluid, right? You're normally not going to put a computer into a hospital room. You're going to have the nurse is going to come in with her rolling cart or his rolling cart, and they're going to do something on the wireless network and all that good stuff, right? So hospitals are a little bit more dynamic and fluid than like a typical doctor's office. Even though, let's say for example, over here in South 2, well, let's assume this is your doctor's office, right? Hope I can't type. Right, so this is your doctor's office. Well, let's say here you have a computer in every room. So what do you do here? Well, you don't need quite as robust of a wireless system than you would over here. So let's talk about that for a minute. How would you go about designing this? And again, not a wireless expert, but I understand about overlapping channels and all that type of stuff. So on a typical 2.4 gigahertz wireless network, you're going to have, I believe it is 14 channels, something like that. For the sake of argument, let's say 12. Well, the problem with that though is you're going to have, it could be higher than that, but I'm just going to use that as a number. What you can't have is too much channel overlap. So if you got 12 channels, well, what'll end up happening is you need to have enough space in between each channel to where the communication is clear. Because if you have too much channel overlap, because if you have something like this, so we have 1, 2, 3, 4, 5, 6. If you have, say we draw, I'm horrible at drawing circles. Let's say we do this, and then we have 2. Then we have 3. Notice the channel overlap? It's a lot, right? So even though I'm doing my best to try to draw even circles around each one of the numbers, you can't, right? It just doesn't work. So what ends up happening is there's going to be, on the 2.4 gigahertz range, you're going to have a number of wireless channels that you don't leverage. So typically speaking, in a typical 2.4 gigahertz, you're going to use channels 1, 6, and 11. And what will end up happening is there's a 5 channel overlap. So if I was to come over here and erase this, just to make it easier to understand, what you would normally do is you would have 1, 2, 3, 4, it's supposed to be a 4, 4, 5, 6, 7, 8, 9, 10, and 11. Which means you'll be able to have your 1, you'll be able to do your 6, and you'll be able to do your 11. Right? I'm drawing those kind of obnoxious, but you won't have any overlap between any of your other channels. So 2, 3, 4, 5, 7, 8, 9, 10, you won't use those channels. Now, here's the funny part is in a residential environment, whether it's an apartment complex or it is in your neighborhood, you're probably going to detect other wireless networks. And there's a chance that the wireless is going to be semi-smart and it'll be able to detect what's going on around it. And so I might be on channel 1, my neighbor might be on channel 3, my other neighbor might be on channel 5. So there might be some overlap. Well, you do your best. And that's why you typically are going to let your access points that are semi-new, you're going to let them dynamically change for you so that you don't have to sit there and monkey with it. It's going to do the channel checking for you. It's going to be like, oh, there's another AP that's on the same channel, so I'm going to change my channel from, say, 3 to 6 so that I give myself some space to work with. And this will, if you have too much overlap, you will run into bandwidth issues and stuff like that. So there are some legit reasons why you would want to do this. Now, coming back over to here, one of the things that you would have to do, and again, this is one of those things that you'd have to send somebody on site, and the idea is you would do a wireless site survey. And a wireless site survey is going out and looking for a couple of different things. Like, okay, where would I optimally place my access points on this particular floor? And then where are there like RF interference? Where are very thick concrete walls? Where are there microwaves? Where are there competing wireless other wireless signals that I might not be aware of? Like, where's a microwave oven? Or, there's a number of different things that you could potentially run into with RF interference. The bottom line here is your goal is to try to identify these areas of interference, and then you're going to use software to kind of figure out what would be the best place to put your access point to combat the RF interference, but also give the best wireless coverage you can. I mean, it's never going to be perfect, but it could be better than others. So, for example, my home office, I am on the opposite side of the house from my wireless access point. My wireless access point happens to sit in my living room. So my living room and then my kitchen. So my kitchen is in the back of the house, my living room is in the front of the house, and there's a wall separating the two that's got an open top. So the wall goes up about 8 feet, and there's a 3 or 4 foot area that's open. So it's kind of open concept in that respect, and I do have vaulted ceilings in my house. So what I did was I ran an Ethernet cable from my basement up through the floor, up the wall, to don't respond. Up the wall to my wireless access point. My wireless access point sits on top of the wall, which gives the majority of people the best wireless access that they're going to get. It's centralized in the middle of the house. That's probably the best place I can put it. Now, there are other places I could put wireless. I could put it in the basement. I could put it in in my office, and it could service other, my wife or my son's room, stuff like that. But I don't have a single access point covers my house. About 2,000 square feet. That's about the size of a typical SSID coverage area. It gets the job done. Is it the fastest Wi-Fi? No, and it's not meant to be. I'm not trying to set land speed records. I have a need for Wi-Fi, and I'm also a network engineer, so I understand what the basics are. So what ends up happening here is, no, I didn't do a site survey. I literally just was like, oh, this seems like a good spot. So, and it has for the last 15 years that I've had Wi-Fi in my house. That's basically where it's at. Now, what will end up happening is in a hospital where there is a much larger density for Wi-Fi, and you got all these rooms off these wings that are doing that have patients in them, and then over here, the main area where you've got offices and cafeteria and walkways and all this other stuff that does need Wi-Fi too, but not as prevalent as the patient rooms. What you would do is you would start deploying access points. Well, the idea here is the APs, their coverage area should be big enough to cover a few rooms. So let's say, for example, that is where you're going to do. So I'm just going to draw these out so that they are, you know, they're somewhat overlapping, but they're not overlapping in the respect that it's obnoxious, right? So we have something like this. Right, so let's say that's our wireless deployment. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 access points that we did per floor. Well, what we'll need to do is we'll need to figure, okay, what channels can I run? And remember, we got 1, 6, and 11. So I would say I'll run 1 here, I'll run 6 here, I'll run 11 here, I'll run 6 here, I'll run 1 here, I'll run 1 here, I'll run 6 here, I'll run 11 here, I'll run 1 there, I'll run 1 here, and I'll run 6 here. So you can, because of that, you can pretty easily go through and lay out your wireless RF channel breakouts so you don't have any non-overlapping channels, so it gets the job done, right? You're able to deploy your wireless network semi-efficiently. Now, granted, I'm giving you a very remedial explanation of how wireless works, but in my experience, this is essentially what it is. That if you like have this burning desire to want to dive into wireless, this is what you're going to have to go learn how to do. So now, mind you, some people will be the site survey person where they're going to go figure out how to do all that type of stuff. Other people will be like, okay, well, we've got that figured out. They know way more about wireless, and so they're going to dig into how all that type of stuff works. So, in my experience, I will be the guy that will set up your VLANs and your trunking, and you'll be the guy to deal with all the wireless stuff. So, it's not hard. It really isn't. It's to me, it's its own level of expertise, and if you become a wireless guy or gal, that's going to be your thing. You're going to be the one that's going to come in and you have to understand how all that type of stuff works. I spent quite a bit of time after I got my CCIE going through wireless because I figured, okay, that's going to be the next big thing, because what is the next most common thing that I deal with is going to be wireless. No matter where I work, there's always some sort of wireless implementation. So I learned quite a bit about it, but I've also forgotten a lot because I don't deal with it on a regular basis. So that is how I would explain to somebody at a decent level how wireless will come into play and how you can work with it and go through and do all that type of stuff. So just be mindful that there's more to it than that. And one second. So if you want to know more, there's plenty of awesome resources out on the internet. I personally, if you wanted to dig into wireless in depth, I would point you over to Network Dojo. They're a former IP expert engineer works over there, Jeff Rensink. I've met him a few times. Nice guy, super knowledgeable on wireless. He's like the only person I know that's doing like any really good wireless training. So networkdojo.com. I'll try to remember to put a link in the description when I post the video to talk about that. But if I was going to go anywhere, I would do that. There's also a good Cisco press book for designing and deploying wireless networks by, one second, let me clear the screen off here. If you need to, take a screenshot of that so you understand, or take whatever notes. But if you go to Google, let's go to the Googles here, and we look at Jerome Henry? Yes, this guy right here, Jerome Henry. Start puzzle. Use the two areas rotating them with face them. Oh. Okay. So Jerome is one of those super smart dudes when it comes to wireless. He's a CWNE, wireless ECIE, stuff like that. So one of the books that he did, I'm not sure if it's going to talk about him or not, but if you were to look up the Cisco Press Wireless, yes, this guy right here. The Enterprise Wireless Design, yeah, this is the book I'm talking about right here. And implementing, yes, I think this is the one. So if you were to get this book right here, it covers both, and he is the primary author on this book. I have not read it personally, but it's, to me, if you're going to dive into wireless, this is the book you need to be getting. And then the other guy here is going to be Network Dojo. If you want to dive into wireless, I would definitely come check out Jeff's content. He's big on CCIE wireless, really strong on that. That's Jeff right there. He's a Wi-Fi CCIE. So he is, I think, that one of the only people that I know of that has gotten people to pass their wireless CCIE. So he did it for IP Expert back in the day, and so it's if you're gonna do something, that's what I would go. I would definitely go check out his content if you're looking for wireless content. So that's just my recommendations for wireless stuff. There's, one thing that I did do is I went out and I did get a couple of 3702 APs. And I do have a 2504, and I'll show you what I mean by that. So if you go to eBay, Cisco 2504 wireless controller, and we were to look at 2504. This is an older AP, but what you would want to do is, this is actually the one that I got right here with the 5 AP license. So you need a license to join access points to the controller. So what I would do is I would go buy something like this with the 5 AP license, $75, and then you pay like another, I don't know, what's Cisco 3702 access point. So you can get, they're $20, $20-$30. You can get a couple of APs. So $20. I don't know how many this guy has for sale. One, let's say, yep, that's good to know. Let's say we're going to go buy 9 available. Let's say you go get 3. So you're paying $16 a pop, and you buy now, so you get those. You're paying a little over $100, $120, and then whatever shipping is. That's what I would do. If you wanted to dig into wireless, go buy yourself a controller. Go buy yourself a few APs, just to get your feet wet, and then you can start diving into the CCNP Enterprise Wireless book, and then once you're like rock star there, then jump over here to Network Dojo if you want to go after your IE. So that's just if I was going to go about doing it, that's probably how I would attack it. So I'm going to try to point you in the right direction based off of what I know. So if you guys have any more questions, feel free to leave me a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine folks in the next video.